Last class we discussed about elasticity, problems based on it. Now we take one more segment, that is energy. In question number 21, energy is involved. This is not previous year question, just basic question it is. What energy? You don't need to discuss much about energy. You don't need to remember anything because I told you already, entire elasticity comes under like spring, F is equal to Kx, right? Now, once F is equal to Kx, if I ask you potential energy of the spring will be half Kx square, right? Same way here, same thing you can use. So if you convert this formula into elasticity, F is equal to what is K Y A by L into X. Similarly, potential energy U is equal to half Kx square. What is K? Again, Y A by L into X square, sorry. X can be, it should be replaced with delta L square. So this is delta L. Okay, right. Now, if you want, you can further develop this one a little bit more. Okay, so observe, I can do one thing, multiply with L and divide with L. 1 minute. Let me write the entire formula once again. I'll multiply with L and divide with L. Now, if you observe this, this will be half Y into delta L by L whole square. Delta L by L into delta L by L into AL. Now, observe carefully. Stress is equal to Y into strain, right? That implies stress is equal to Y into delta L by L. So Y into delta L by L can be replaced with what? Stress. And delta L by L is strain. So if you do that, okay, and 1 minute, let me continue this entire thing here. And this is a small part that I took. Just a minute, this is a small derivation. Sideways now. Yeah. Now observe this. This can be written as stress. This is strain. Area into length is volume. So energy can be written as half stress into strain into volume V. Or if I take volume on this side, energy by volume is called as small u. What is small u? Energy density, that is equal to half stress into strain. If you're interested, you can remember this formula. But anyway, my final statement is no need to worry about this. You don't need to remember much. Why it is not detecting box? Yeah. You need not memorize much. Just simply remember that, half Kx square, where x is equal to Ya by L, K is equal to Ya by L and x is equal to delta L. That's it, over. So that's sufficient. So you don't need to remember much about energy, which is already there in your brain. You can use those formulas and deal with it. Okay. Now let us go ahead with that. So energy U is equal to half Young's modulus 1 into 10 power 11 Y. Area is 0.1 centimeter square. So 10 power minus 5 Ya by L. Length 10 meters by L is by 10 into delta L. Stretched by, everything is given. 1.0 millimeter. Right? That is 10 power minus 3. Observe whole square. Why square? Because observe the formula. Ya by L into delta L whole square. So it's a matter of mathematics. That's it. So 10 power 10, it will be minus 5 will make it 5. This will be 10 power minus 6 and 10 power 5. So it will be 0.5 into 10 power minus 1. Oh, they want in terms of 10 power minus 2. So 5 into 10 power minus 2. So answer is 5. So if you are interested, you just remember this discussion or else just leave it. Directly take what? Tell me. U is equal to half k x square. K is ya by L. X is equal to delta L. Solved. Go ahead with question number 22. Question number 22 also relatively easy question. It's based on simple energy concept. Okay. A metal wire of length 2.0 meter and a cross-section area 0.1 millimeter square has Young's modulus 2 into 10 power 11 Newton per meter square. Okay, good. A block of mass 4 kg is attached to one end of the wire and other end is attached to the ceiling. Good. The energy stored in the wire is, in this case, observe, elongation is not given. In this case, elongation is not given. So we have to calculate elongation. If you want, you calculate and substitute, or else you derive the formula. Sir, purila. I'll explain. U is equal to half k. K is nothing but ya by L into x. X is nothing but delta L whole square. Now delta L is not given. You can do one thing. F is equal to kx ya by L into delta L. So by using it, you calculate delta L and then substitute here. It is a little bit lengthy. Or directly you substitute the delta L value there. That is equal to what? Tell me. That implies delta L is equal to F into L by ya. Right? Now, if you substitute this delta L value over there, it will be U. That implies, wait, this is sideline derivation. That means, one minute, this is a sideline derivation. Let us keep it aside. Yeah, good. That implies U is equal to half ya by L into delta L square. Delta L square is F square into L by ya whole square. Observe, exactly we have the reciprocal here, right? These two gets cancelled. These two gets cancelled. And now you end up at the formula that half F square into L by ya. You can use this formula. You can use this and you get the answer there. So energy U is equal to half. What is F? F is 4 kg and take G is equal to 10 is given, right? So 4 into 10, 40. 40 square. 40 into 40, I write. Into L. What is L? Length is 2 by Y. What is Y? Y is 2 into 10 power 11 into area. What is area? 0.1 millimeter square. Millimeter means 10 power, millimeter square means 10 power minus 6. 0.1 is there, so it will be 10 power minus 7. Now it's a matter of simple mathematics, that's it, right? So 2 gets cancelled. 2 how many times? 20 times. And 10 power minus 7. 10 power minus 7, this will be there. So 11 minus 7. 4. This 4 go to numerator. It will be 10 power minus 4. Yes. So 800 into 10 power minus 4, right? Or I can say 80 into 10 power minus 3 joule. Observe, millijoule is clearly given there. So this entire thing is milli. So I can write like this. The finally energy U is equal to 80 millijoule. So answer will be 80 here. Answer is 80. As already explained, in question number 24, we have graph. We already explained, whenever graph comes, you need to find a relation between the quantities given in the graph, stress and strain. And observe, they're asking energy density. They're asking what? Energy density. So we know the formula also, if you can remember good, or you derive it. Energy density formula, small u is equal to half stress into strain. Half stress into strain is the energy density. Now you know very well stress is equal to Young's modulus into strain. Now logic is very simple, that we have write two formulas And just we need to substitute. Suppose if you want, strain is being given, stress is not given. So replace stress with Young's modulus into strain, you have to substitute. So replace stress if it is not given, replace strain if it is not given. Whatever is given there, then you need to check it. Now observe what are the given data. That energy density of a linear strain is given. Check it. Here strain is given. That means this is given. Stress is not given. Okay. So what we do, we take it like this. Above two equation will lead equation U is equal to strain is already given. So you have to replace stress. Stress is equal to, energy density U is equal to half into Y into strain. Strain square. But strain is not a problem. The problem is only Young's modulus. How do you get it? Now you know very well this formula. If you observe, stress is equal to Young's modulus into strain. This is strain. This is stress. Then the slope of the graph is what? Strain by stress. Oh, be careful. It is not Young's modulus. It's reciprocal of Young's modulus. That's a tricky one, right? You may feel, but observe if you want to convert this strain, stress, strain on y-axis. So small y, stress on x-axis, x is equal to capital Y. Check it. This is the formula. This is the formula, tricky. So x is equal to Young's modulus into y, or else I can say y is equal to 1 by capital Y into x. Tricky. Good question. Maybe you may take slow. So no need to worry about it. We concluded Young's modulus y is equal to 1 by m, or slope, reciprocal of slope. So for a straight line, slope is constant. You can take between these two or any two you can take. Then you don't need to discuss much. So I'll take the easiest one, first one. Reciprocal of slope directly I'll take. That is equal to delta x by delta y. I repeat, reciprocal of slope delta x by delta y. Delta x is 20. Be careful, check units, Newton per meter square SI by delta y. Delta y is 10 power minus 10. Oh, 10 power minus 10. Units are not given. They might have given units, but anyway, if not given, we have to take only SI units. So it will be what, tell me? 2 into 10 power 11. Now, Young's modulus is there, strain is also there, then it's a simple substitution, right? Half, what is Young's modulus? 2 into 10 power 11. And strain is what? 5 into 10 power minus 4 whole square, right? So 2 gets cancelled, and it will be, I can say, 25 into 10 power 11, and this is 10 power minus 8. So into 10 power 3. This is energy density, joule per meter cube. But check it, they gave kilo here, kilo. 10 power 3 is kilo. So answer is, let us put therefore there. Therefore, U energy density is equal to 25 kilojoule per meter cube, right? So answer is 25. This question is very straight and easy one, but only small point you need to know. Strain of 0.04%. What is that? See, we know very well strain is delta L by L. That is equal to 0.04 percentage, right? Sir, that does means it's 0.04 tappu. 0.04 percentage is little tricky one. Be careful. Okay. 0.01 percentage means that is equal to 0.04 by 100. By 100. So I can say 4 into 10 power minus 4. This is the only point I would like to tell you, that you have to remember that when it is given percentages, you have to divide with 100. Otherwise, you'll go wrong. Okay? Right. So now after that, everything, Young's modulus is given, strain is given. So observe, energy density they are asking. Energy density formula U is equal to half stress into strain. And observe, they gave strain value. Stress has to be eliminated. So I can replace stress with what? Young's modulus into strain. Now strain into strain is what, tell me? Strain square. So now after this simple substitution, half Young's modulus is given 7 into 10 power 10 into strain. Strain is 4 into 10 power minus 4. So it will be 4 square into 10 power minus 8. So I can say 10 power minus 8, this is 2. So 2, how many times? 4 square 16 means 8. So 56. 5600. Once you got 56, then immediately you have the answer. You don't need to get remaining 2 zeros or something, but it's okay, fine. Okay, 5600, answer A. Remember, this is April 2023. That means very close to recent problem. So you need to. Okay, go ahead with the next question. Question number 26. I can say we learned energy in the previous segment. Only just we are calculating energy. But whenever we calculate energy, we use law of conservation of energy. We use that energy to generate some velocity or project or something like that. Now, a stone of mass 20 grams is projected, okay, from a rubber catapult of length 0.1 meter and area of cross section 10 power minus 6 meters square, stretched by an amount of 0.04 meter, whatever it is. Velocity of the projected stone is. This is the thing I told you, na, that we link elasticity with mechanics. That's the thing you need to understand. That linking will be like this. See, the energy U is equal to half kx square, half k, what is k? Ya by L into x is what? Tell me, delta L whole square. That is equal to half y, 5 into 10 power 8, because this is 10 power 9. So I made it 5 into 10 power 8. Y into what is area? 10 power minus 6. Ya by L. Just a minute. Yeah, by L. Length 0.1 meter. 10 power minus 1 I'll take. Good. Delta L. 0.04 meter, right? Delta L square. So it will be 16 into 10 power 0.4 meter. 0.04 meter. 10 power minus 2 square will be 10 power minus 4. Good. Let us calculate. 2 how many times? 8 times. And 10 power 4, 10 power 6 minus 10. And this will be minus 2. Denominator 10 power minus 1 is there. So this is 10 power minus 1. So ultimately you will end up at 10 power 1 there, or 10. So I can say like this. This is 10, this is 8, this is 5. Means 400. This is the energy. If this energy converted to kinetic energy, initial potential plus kinetic is equal to, let me write the formula. Yeah, I'll write the formula. U initial plus K initial is equal to U final plus K final. That implies initial and potential energy is 400 in the string. Kinetic energy is 0. Finally, string will be relaxed. Of course, there will be some loss in energy, sound and all these things, but ignore. Kinetic energy is half m 20 into 10 power minus 3 grams, na? V square. That's what we need to calculate. It's a simple mathematics. This is 10. 10 will be minus 2 times. Minus 2 will go there, plus 2 it will be. That implies V square is equal to 400 into 10 power 2, right? That implies V is equal to square root of 400 is 20, 20, it will be 200. Got the mistake? 10 power plus 8 minus 6. It will be plus 2. Plus 2 minus 4 will be minus 2. So 10 power minus 2 is there. 10 power minus 1 in denominator. So it will be 10 power 10 power minus 1. 10 power minus 1 and 8 into 5. 8 into 5 how much? 40. So 40 into 10 power minus 5 will be 4. So energy is 4 joules. There is an error. So then it will be 20 meter per second. Now we discuss a new topic, that is bulk modulus, right? Importance wise little less, but in NEET JEE point of view, but it is relatively important than rigidity modulus. That's the least important, I can say. Bulk modulus is there. The symbol will be B or K. K is there in the CBSE. You can take B also. Okay, bulk modulus. What is this bulk modulus? See, we are discussing about stress and strain. So volume or bulk stress is directly proportional to volume or bulk strain. We are dealing with stress-strain relation only. Previously, it is linear. Now it is volume. Volume stress is proportional to volume strain. So I can say this volume stress is equal to some proportionality constant K into volume strain. Volume strain. This is the relation. You know very well, linear stress is equal to Young's modulus into linear strain. That formula we know already. Same thing here, but here the body will change its volume. So if you want to go to the formula, I can say stress is equal to force by area is equal to K bulk modulus into volume strain is delta V by V. Okay, so generally, if you go to the practical application, it is easy to increase the length of a wire or something by simply holding between your hands. You can stretch it a little bit, but volume is little difficult. Sir, suppose if you take an object like this, you have to compress it entire volume. That means you should not apply force at one particular place. Throughout the body, you have to apply the force. Okay, it's little difficult. The best way to deal with is take deep into water. It will compress from all sides. So once you got the point that this is practical, I'm telling you. Practically, if you want to compress something from all sides, the easiest way is take it to water or liquid. Any liquid you can take. Now, fluids comes into picture. So little bit of information I'll give here about fluids. As you go deep in a liquid, the pressure will change. So at this point, pressure is P1. At this point, pressure is P2. You're going deep. 2 points I'm taking. In a same liquid, you have to go for same liquid, not different liquids. The formula you need to apply, I think you know already, but just you need to apply. Pressure at lower level, P2, lower level will be high. As you go deep, pressure will increase. P2 is equal to P1 plus rho GH, where rho is the density of the liquid, G is the acceleration of gravity, H is the depth that you are going deep, that how deep you go. P0 plus rho GH. There's a one formula which you need to remember, and maybe you need to apply it here, because I can say like this, bulk compression is possible only by taking into water, practically speaking, if they speak about it. Okay, so this, I think this formula is also kind of important for you. Apart from that, remaining is easy to deal with. You can make it. Small topic is there we need to explain, that compressibility. Compressibility. How much it is compressible. That's what the meaning of it. Compressibility is 1 by bulk modulus. That's it. This is not a big topic. Or see, sometimes we define new concept or new quantity we define. This is, here we are defining compressibility. When we define new quantity and we start developing some mathematics with it, something like, if you recall, we defined something called a strain, change in length to original length, or change in volume, original volume. Then we develop some mathematics based on it. So further development is there. But in this case, no. Compressibility is 1 by K. That's it. If C value is very, very high, it is highly compressible. Low means less compressible. There ends the matter. There is no further development. Okay. This is the thing you need to learn about bulk modulus. Small concept. Okay. That's all. We'll continue with the problems. Question number 27. A certain pressure P is applied to 1 liter of water and 2 liter of liquid separately. Good. Water gets compressed by 0.1%, whereas the liquid gets compressed by 0.03%. Okay, right. The ratio of bulk modulus of water. This is a simple ratio it is. So force by area is equal to bulk modulus into change in volume by original volume. Okay. Now what I do is that what is the given data? Certain pressure P. Okay. That means here the force by area pressure is same. Force by area pressure is same. Change is given in percentages. Okay. So this one is constant. Then proportionality equation will be bulk modulus is directly proportional to V by delta V. My God. I'll do one thing. Instead of writing V by delta V, which I don't like, I write 1 by strain. Strain is ST, I write. Good. So that implies K1 by K2. I'll go chronological order. 1 is water, 2 is liquid. Is equal to strain 2 by strain 1. That implies strain 2 is equal to, that implies bulk modulus of water to bulk modulus of the liquid will be strain 2 0.03. Sir, percentage means by 100. No need to worry about it. It gets cancelled on both sides. So no need to worry. 0.01 is equal to 3 by 1. So the value is 3 by x. What is x value? 1. So answer is 1. Sir, it is easy, very easy. Reason is very simple. See, right now you're studying about bulk modulus. That's why the formula is in your memory. But remember, memorizing this in the examination hall, because this topic is so remote, you may not have good memory there. So we need to remember the formulas and get to the examination hall, deal with it. This is a relatively easy topic. Question number 28. A solid sphere of radius r of a soft material and bulk modulus k is surrounded by a liquid in a cylindrical container. Okay, that's fine. No problem. A massless piston of area A floats on the surface of the liquid, covering entire cross section of the cylinder. Okay. When a mass m is placed on the surface of the piston to compress the liquid, the fractional decrement in the radius of sphere is. Yeah, it's a good one. We have a diagram here. Container is there and we need a piston there, right? So let us give the different color here to the piston. Piston is there. Yeah. I have the piston, but massless piston. Piston doesn't have mass. And now what they did is that they placed a block of mass m on top of it. Good. They placed mass m on top of it. That's the key thing. Okay. Now what happens? A solid sphere of radius r. Oh, wait. I need to make a solid sphere of radius r. It's there inside. Okay. When mass m is placed before this and after this, what happens? Very simple. It is not changing its position. So definitely the pressure won't increase or decrease because of depth. But by adding mass, you are increasing pressure there, right? That's a key idea. Formula is F by A is equal to, sorry, I'm getting Y. Bulk modulus K into delta V by V, right? But wait a minute. Sir, for F by A is pressure. Yes. Remember, you can take pressure also. And in case of bulk modulus, you can take delta P also. Just remember this. This is a one small thing. Delta P into K by delta V by V. Okay. Delta P also you can take. So let us continue. Delta P increment in pressure. Increment in pressure is already some pressure is there, but now by adding mass m, pressure will be mg by A is equal to bulk modulus K into change in volume by original volume. Wait. How to deal with this change in volume by original volume? But here radius they are asking. Huh? Observe, volume V is equal to 4 by 3 pi r cube, small r, sorry. If I take dV, dV is equal to 4 by 3 into 3 pi r square dr. Now, if you divide them, if you observe that if you divide these two, instead of dividing 1 minute, you have to divide in the reciprocal. That's the best option. If you divide the reciprocal, that will be dV by V is equal to, observe this 4 by 3 pi, this 4 by 3 pi gets cancelled. And r square, r cube also gets cancelled. Check the calculation. Then it will be 3, it will be. So 3. Then this will be mg by 3. Answer is Charlie C. Perfect. 28th one. The core idea here is that adding mass will increase the pressure. 29. The normal density of the material is rho and bulk modulus is K. Magnitude of increasing density of the material if the pressure P is applied uniformly on the all sides. So because of, assume that there is a sphere or something, if you apply pressure from all sides, then it comes under bulk, it's fine. But what happens is that volume will decrease and density will increase. That's what the key idea. If you pressurize from all sides, volume will definitely decrease and increase. So you need to understand link between decrement in volume, increment in density. So observe density is equal to, you need to write this one. Density is equal to mass by volume. By compressing it, actually mass won't change. That implies I can say like this. Delta rho by rho is equal to, as mass is constant, I can say minus delta V by V. Right? Fractional change. Or d rho by rho is equal to d rho by V. That also you can do. So ultimately, the variation of density depends on variation of volume. So delta V by V is very easy to calculate. Bulk pressure or force by area is equal to bulk modulus into change in volume by original volume. That implies delta rho by rho is equal to P by K. P by K. Okay. So now, sir, minus sign. Accept it. 1 minute. Symbol P rho looks alike, right? This is P. That implies minus sign will be there as it is. I'll keep it. Delta rho is equal to minus P rho by K. Small problem is there. That's a minus sign. Actually speaking, increment in pressure will decrease the volume. There is one more minus sign there. If you apply that, then this plus will come here. Check it. Density will increase if you compress the body. It becomes more and more denser. So plus. Reason is delta V by V itself is negative. So minus or minus, it becomes plus. Right? Delta V by V, in this case, increasing pressure, it will be negative. So this is the answer. So answer for this is B. Go ahead. Question number 30. I told you already, as you go deep, pressure will increase. So if you take 2 points, right? Let us take this point. At this point, pressure is P1. At this point, pressure is P2. Depth is H. So formula is already given. pressure at depth is equal to pressure at higher P1 plus rho GH. This formula is from fluids. I think you know this. We'll continue. Now, where the rubber ball is taken to depth of something, the deep sea, the volume decreased by 5%. Good. So let us write like this: delta V by V is equal to 0.5%, right? 0.5 percentage. It will be 0.5 by 100. So I can write 5 into 10 power minus 3 delta V by V. Observe, sir, actually pressure is equal to bulk modulus K into change in volume by original volume. Yeah, you can take it, first point. Yes, you can, but sometimes we take delta P also, I told you. So here, P2 minus P1 is delta P. So if you want, you can take a shortcut. Delta P is equal to rho GH. So this value can be directly replaced with rho GH. That implies rho GH is equal to K into delta V by V. Now substitute the data, you'll get the answer. Rho, density of the water, 10 power 3. G, 9.8. Wait, I'll take it to the next line. Yeah, I'll take it here. Yeah. Rho GH. So that H we have to find is equal to bulk modulus of the rubber, 9.8 into 10 power 8. But anyway, no need to worry about 9.8 and 9.8 gets cancelled, right? Yeah. K into, wait a minute, delta V by V. Delta V by V is 5 into 10 power minus 3. Depth. H is equal to 5 into 10 power 2. Oh, it has to be 500 meters deep. But yeah, that's the answer. Half kilometer you have to. Answer will be 500 meters deep. Correct answer. Correct. This is also same logic, you know. An object is located 2 kilometers beneath the surface of water. Good. The fractional compression delta V by E is 1.36%. The ratio of hydraulic stress to corresponding hydraulic strain will be stress to strain, right? Sir, what is this hydraulic? Hydraulic is nothing but bulk. Is equal to bulk modulus K, right? Oh, they want me to calculate K. Okay, fine. So stress is equal to depth is given rho GH, right? Rho GH. So 1 minute. I'll recall the formula. Delta P is equal to K into delta V by V. So delta P can be written as rho GH. That is equal to rho GH is equal to K into delta V by V. Ultimately, they want K. Fine. Then we can calculate rho 10 power 3 kg per meter cube. G 9.8 they want. Okay, fine. 9.8 into height H 2 kilometers. 2 into 10 power plus 3 is equal to bulk modulus. That's what we need to find. Delta V by V 1.36 by 100. 10 power minus 2 is the value. So what I do is that 10 power minus 2 will cancel. 10 power minus 2 will go, that become plus 2, 5. This also 3. 10 power 8 will come here. Good. K is equal to 9.8 into 2 by 1.36 into 10 power 8. I need to find this value. 9.8 into 2 by 1.36. 14.4, correct. 14.4 into 10 power 8. Therefore, bulk modulus K is equal to 1.44. Something is there, we stop it here, into 10 power 9. Answer. Yeah, units is Newton per meter square bulk modulus. Because stress has units Newton per meter square, strain doesn't have any units. So that's it. Good. We discussed about very little basics of this sharing. Now we discuss about shear modulus, right? We'll discuss. This is already explained, but anyway, I'll explain once again. Assume there is a block which is being rigidly fixed at the lowermost point. And right now, we don't apply force normally because in Young's modulus and bulk modulus, we apply force normal. Right now, we don't apply normal, we apply tangential. That's called shearing, okay? By applying force, what happens? The topmost layer will move slightly forward. So what happens is that it generates kind of shear. It will be like this. Dotted diagram is the new position of that new shape of the body, shearing. This shearing is measured in this way. This angle theta is the shear strain. Shear strain is that angle. But anyway, you know very well, this is small triangle it is. For small angle, sine theta nearly equal to tan theta is equal to theta. If you want, you can use shear strain as theta, or you can use the change in length is delta x and this perpendicular length is L. Sir, why don't you use delta L here? Generally, if I write L and delta L, then I got a misconcept that both are in same direction. Here they're perpendicular. So for my convenience, that means I don't want to have a confusion there. That's why I use delta X over there. That's it. You can use delta L, L also. Capital L, small l, whatever you want, you can use, is your choice. So what is the thing is that strain, shear strain is already explained. Again, I'm explaining. Shear strain is equal to theta you can take or delta X by L, the shear strain. Anyway, you know Hooke's law, we already discussed. You can say, according to Hooke's law, shear stress is equal to shear strain. Right? Now, stress is equal to force by area into, wait. Sorry, I did a mistake. Shear stress is proportional to strain. Then the proportionality constant, I'll replace that proportionality constant with eta. That proportionality constant eta, that is called as shear modulus. Okay. So F by A, eta, shear strain, delta X by L. You have to remember this. Sir, in exam, I can develop it. Yes, you can develop, because if you understand the basic idea here, then you can develop this one in the examination. No problem at all. Again, strain doesn't have any units. Stress has force by area. Eta also will have force by area. So Newton per meter square. Okay. That's it. In this regard, if I check entire previous year mains book, only one question is given. That is question number 32. That you can solve. A square aluminum shear modulus is already given. Slab of side 60 centimeter in thickness, 15 centimeter is subjected to shearing force on its narrow face. Which is difficult it is. Square, I think it's cube, na? But anyway, it's so fine. Let us understand. The lower edge is riveted to the floor. How to, first of all, we need to think a little bit. You study question carefully, you will understand that there is square plate of thickness like this. So you need to understand that there is a square plate. This is a square, side view I'm giving. And thickness is there. So it is actually, it's cuboid, maybe. Continue. And then the point is that subject to shearing force, the lower edge is riveted to the floor, fine. But on its narrow face, this is a narrow face, check it, not this one. So if you try to make the diagrams that, lowermost point is fixed and there is a square, this entire square is there, the lowermost point is this one. I'm keeping it here, okay? Good. Then what? We apply same standard stuff. Apply force F, it will deform, and shearing is theta, delta L and delta X, and standard stuff. Displacement to the upper edge, delta X is required. So force by area is equal to shearing modulus into delta X by L. Nothing right now. I personally feel that easy solved. Force is 18 into 10 power 4. Good. Area is equal to length into breadth. Length is 60 centimeter. 60 centimeter means 6 into 10 power minus 1. Thickness 15 centimeter. 6 into 15 into 10 power. 6 la 10 power minus 1 is there, and 15 la minus 2 is there. So minus 3 is equal to eta. Eta is 25 into 10 power 9. That's fine. Into delta X by L. By L. What is L? Length. Wait a minute. This length is nothing but again 60 centimeter, right? 6 into 10 power minus 1. Yeah, the 6 and this 6 gets cancelled. 10 power minus 1 will be minus 2. Good. 10 power minus 2 will be 10 power 6. You have to be a little careful here. 10 power 6 cancel out, right? 10 power 6 will be 3. That implies delta X is equal to 18 by 15 into 25 into 10 power minus 3. But I want in micro, right? So let me simplify this. 3 5s are 3 6s are. So that is equal to 24 by 5 into 10 power minus 5. 48 into 10 power minus 6 meters. So this is micro. So my answer is answer 48. Now we discuss about Poisson's ratio. Right? Let us consider there is a rigid support ceiling and there is a rod. When you apply force at the end of the rod, the length will increase. Obviously, you know that. But you need to understand one more thing. The thickness will decrease. So let us write the data. This length is L. L plus delta L. Where delta L is the increment. But observe, if the radius of this is R, this will have radius R minus delta R. Some decrement will be there. No doubt about it. So, longitudinal strain, we know this. Longitudinal strain is equal to change in length by original length. That's fine. But there is a strain in thickness or radius also. That is lateral. We call it as lateral strain. I will take like this. Lateral strain is delta R or dr. Okay, delta R by R. Now the definition of Poisson's ratio, sigma, okay, is equal to lateral strain by longitudinal strain. That implies Poisson's ratio formula will be delta R by R into L by delta L. But if you substitute directly the formulas there, okay, what happens is that generally when length increases, this delta L is positive, R will decrease, one negative sign will come. So we don't want to have a negative sign for sigma. So delta R by R is negative. We take. So this is how we define this one. Generally, theoretical value of sigma will be theoretical value because of the theory length increase this much something right? Volume conservation, something we take. Theoretically, the value can be anywhere between -1 to 0.5, but practically it will be 0 to 0.5. Practical. And we need to find the relation between these variables. Now we don't derive this. We need to take by default, like, 9 by Young's modulus is equal to 3 by rigidity modulus plus 1 by bulk modulus. This is given as synopsis to you. Remember that. Then the Poisson's ratio sigma is equal to 3 times the bulk modulus minus 2 times the rigidity modulus by 6 times the bulk modulus plus 2 times the rigidity modulus. Two formulas are there. Derivation is out of requirement and all these things. Just remember this. And there are 2 questions in mains based on this. Question number 33 is relation between elastic moduli. There you have to memorize and deal with that, so nothing else. Okay. So sigma value is 3 times bulk modulus K minus 2 times this one. Answer is this one, A. Directly you have to remember the formula and deal with it. There is no option. So answer is A. 34, last one. And this is also relation between them. Bulk modulus, rigidity modulus and all. We know the formula. 9 by Young's modulus is equal to 3 by rigidity modulus plus 1 by bulk modulus. We know this. We need to deal with all these things, right? Yeah. We have to solve all 3 because check it in the ABCD options. They give y, eta, and we keep our fingers crossed and we'll try for first one. Y is equal to 9 into, I take y here and I take LCM and this one, eta k by 3k plus eta. Ayyo. Bad luck, it is minus here. We have plus. So we can rule out, okay, good. C and A we can rule out. They are ruled out. Now we have to go for eta. Do one thing, yeah. 3 by eta is equal to 9 by y minus 1 by k. That implies eta is equal to 3 into yk. Yeah, numerator is fine, but denominator is not fine. 9k minus y. I'm getting minus, there plus is there. So ruled out. So you can rule out these 3. So answer is D, but let us solve it. K is equal to, oh wait. So what I do is that 1 by k is equal to 9 by y minus 3 by eta. That implies k is equal to cross multiplication y eta by, absolutely right, because y into eta, it will be 9 eta minus 3y. Yeah, correct. Bad luck. D is the answer. Anyway, in examination hall, once I rule out A, B, C, I won't spend time there. I'll mark D and I'll go ahead.